Good noon everybody. আমরা আজকে সেকেন্ড ক্লাস স্টার্ট করব। ফার্স্ট ক্লাসে আলোচনা হয়েছিল সিঙ্গেল পার্টিকেল মডেল অ্যান্ড কালেকটিভ মডেল। সেখানে আলোচনা প্রসঙ্গে আমাদের উঠে এসেছিল we have discussed about quadrupole moments. Then we have discussed some related topics about quadrupole moment. Today we will discuss about permanently deformed nucleus and how the nucleus transform from spherical shape to prolate and oblate form, and how their quadruple moment are related with the observed or experimental large quadruple moment. So let us start. Suppose we are starting from a nucleus of perfectly spherical shape. Now, due to some reason, the spherical shape is deformed, but not too much. Its symmetry is retained. To retain the symmetry, the sphere has to be oblate sphere or prolate sphere. Now, in order to describe the deformed nucleus, deformed from spherical shape, coordinate transformation is necessary. For that, we need, as you know, in classical mechanics, you have learned 3 angles known as Eulerian angles are necessary to go from space set of axes to body set of axes. Suppose this is body set of axis. Body set of axis, and we are rotating it x, y, z, and we rotate it x dash, y dash, z dash. These angles here, this is theta 1, this is theta 2, this is theta 3. These angles are called Eulerian angles. These angles are called Eulerian or Euler angles. In order to define the body set of axes, we just consider quadruple equilibrium shape, because as will be discussed later that the monopole and dipole terms will not be dominant in case of nuclear moments. It will only be the quadruple term that will be dominant. So we are considering quadruple equilibrium shape. So the equation can be written as R is the radius, deformed radius, R0 is the radius of the sphere, which is original sphere undeformed, that must be equal to 1 plus summation over mu A to mu y to mu theta dash phi dash. Where y is the spherical harmonics, y2 mu is called the spherical harmonics. Spherical harmonics. Now, in space set of coordinates, you see this part will be 0, because in space set r equals to r0. But we consider that the deformation is in such a small amount such that in this equation also holds summation over mu, alpha twice mu y2 mu theta phi must be equals to the summation over mu A mu to mu, y to mu, theta dash, phi dash. This must be equal. That is the parameter A to mu, which are the deformation due to quadruple equilibrium, are changed from original value alpha to mu nu. Now, as you know, for mu runs from -2 to +2, there are 5 values. That means this coefficient has 5 values: A22, A21, A20, A2 minus 1, A2 minus 2. These are the 5 coefficients are there. Now, if we take the axis to be principal axis, let the axis we are taking let the axis we are taking the principal axis, then these two terms will vanish, will be 0. A21, A2 minus 1, these terms, because these are product of inertia terms, similar to product of inertia term, this will be vanished, and we suppose these two terms are equal. If it is symmetric, A22, these are equal. These two terms are equal. So out of 5 coefficients, 2 coefficients are null and 2 are equal. So we have only 2 variables. Now to express these 2 variables, let us introduce another system, another 2 variables beta and gamma, such that A20 equals to beta cos gamma and A22 equals to A2 minus 2, since 2 terms are there, to beta by root 2 sine gamma, such that beta square equals to A20 square plus A22 square 2. This will be mod, right? And tan gamma will be equals to root 2 A22 by 20. This is the new parameter beta and gamma, and the 3 parameters theta 1, theta 2, theta 3. These 5 new parameters describe the old parameter, which are, say, that quantity alpha, shall I say, alpha twice mu. There are 5 quantities. These quantities were for space set of axis. These quantities has been replaced by 5 new quantities: theta 1, theta 2, theta 3, and beta and gamma, new variables. Now let us calculate difference from spherical shape. From the equation, you can see that r minus r0 will be equal, from the first equation, r minus r0 will be equals to r0 into y, first term is A22 y22 plus A20 y20 plus A2 minus 2 y2 minus 2, because other two terms A21 and A2 minus 21 are 0. Now if we replace the values of y22 and y20 and y2 minus 2 then this comes out to be equals to, and these values of A22 and A21 which are same, which is equals to R0 beta by root 2 root over 15 by 32 pi sine square theta dash sine gamma This is exponential 2I phi dash. This is exponential minus 2I phi dash. So exponential 2I phi dash plus exponential 2I, sorry, minus, should be minus 2I phi dash plus another term will be there for this term, beta cos gamma root over 5 by 16 pi 3 cos square theta dash minus 1. I'm sorry, this is not visible. Oh, now it is visible, I think. Now it is visible, I think. Beta cos gamma, these two terms are there. Now these two sum up to be what? Cos 2i, sorry, cos 2 phi. This will be cos 2 phi dash. These two terms sum up to cos 2 phi. So final expression would be like this. It would be R minus R0 will be equals to R0 beta root over 5 by 16 pi cos gamma 3 cos square theta dash minus 1 plus root 3 sine gamma sine square theta dash cos 2 sine square theta dash cos 2 phi dash. So this is the term R minus R0. Now we can evaluate different axes, say length along x-axis, y-axis, z-axis, depending on the value of theta dash. For say, for example, for x-axis, x-dash axis, say x-axis, theta will be equals to how much? Pi by 2, and phi will be how much? 0. Right? So phi dash. Theta dash will be pi by 2 and phi dash equal to 0. So delta R1 would be R pi by 2 0 minus R0 would be equals to root over 5 by 4 pi R0 beta cos gamma minus 2 pi by 3. Similarly, delta R2 would be equals to R pi by 2, this would be also pi by 2 minus R0, this would be root over 5 by 4 pi R0 beta cos gamma. And delta R3 means along, this is along x-axis, along y-axis, along z-axis, delta R3 would be equals to, I'm sorry, delta R2 would be equals to cos gamma minus 4 by 3, 4 pi by 3. R pi by 2, sorry, I'm sorry, this will be 0 and phi, any value of phi, minus R0 root over 5 by 4 pi R0 beta cos gamma. Now we are taking, for example, a simple value of, cos gamma. which is let gamma equals to 0. Then delta R1 equals to delta R2 equals to minus root over 5 by 4 pi R0 beta by 2, which is less than 0. Means x-axis and y-axis is contracted from the original value. And delta R3 would be equals to, for gamma equals to 0, root over 5 by 4 pi R0 beta. R0 beta, which is greater than equals to 0. So z-axis is elongated. So this will be a prolet sphere of this shape. Say if this is x-axis, sorry, this is x-axis, this is y-axis, this is z-axis, then the sphere would be something like this. It will be elongated along z-axis. This radius will be smaller, and this radius will be larger. This radius will be larger. So this is A, this is B, A greater than B. Now, for other two values of gamma, I am giving you it as an exercise. Please do it on your own hand. Put the values of gamma equals to 2 pi by 3 and 4 pi by 3. Then the sphere will be also prolet sphere. Gamma equal to 2 pi by 3 and gamma equal to 4 pi by 3, and draw the line. This is a homework. Draw sphere. Draw the figure. And for oblate sphere, what would be the value? If we put gamma equals to pi, we put gamma equals to, say, gamma equals to pi, then it will be a prolet sphere, sorry, oblate sphere. Oblate sphere. That is, it will be elongated along. It will be elongated along the equatorial plane and contracted along the z-axis, means similar to the shape of apple. So please also perform, draw the, this is also homework for gamma equals to pi, pi by 3 and 5 pi by 3. Pi by 3 and 5 by 3. For these values, sphere will be oblate sphere. Draw the figure. Draw the figure. Next, we are moving on to quadruple moments. Quadruple moments for deformed nucleus. Next, we are moving to quadruple moments for deformed nucleus. Quadruple moment for deformed nucleus. Now, intrinsic quadruple moment can be expressed as intrinsic quadruple moment, as you have seen in the previous class, which is denoted by Q0. This can be calculated as 3 by root over 5 pi z R0 square beta, where beta is the deformation parameter. If deformation parameter is beta, then quadruple moment Q0 means Q33 can be expressed by this expression, where R0 is the radius of the sphere, mean radius of the sphere, and Z is the atomic number of the nucleus. power of the element. Now we have delta r square. In the previous expression, we have delta r square equal to delta r1 square plus delta r2 square plus delta r3 square. We are taking for cos gamma equal to 1 means gamma equals to 0. If we put these values, then this comes out to be 15 by 8 pi r0 square beta square. Right. Now if we substitute this value of, from here we can see that, from here we can write that beta equals to 8 pi by 15 delta r by r0 root over. Right. If we substitute this thing in this equation, we finally get q0 equals to 3 by root 5 pi z r0 square into root over 8 pi by 15 to delta r by r0. So this comes out to be root over 24 by 5 z, again z r0 square delta r by r0. So this is the intrinsic quadruple moment once we can calculate the value of delta r and the ratio delta r by delta r0. So the idea of intrinsic quadruple moment can be estimated. Now quantum mechanical calculations, we know from quantum mechanics the values are, all the values are discrete values, there is no continuous distribution. Quantum mechanically it can be proved that the quadruple moment q can be written as q0 into I 2i minus 1 pi I plus 1 into 2i plus 3 into q0. This is the expression that we obtain considering quantum mechanically the quadruple moment, where I is the spin of the nucleus. Now obviously you can see that I equals to, for I equals to 0 and I equals to half, q equals to 0. That is the reason for small spin the quadruple moment, or for spin equal to 0 quadruple moment, value of the quadruple moment was very small. But in case when spin is larger, value of spin is larger, the deviation for sphericity is happened and therefore quadruple moment are observed. Now you can calculate the quadruple moment, say q0. You can calculate the value of q0 for Prolet sphere this way. For Prolet sphere, you can calculate ellipsoid charge distribution. You can calculate quadruple moment. Say for this sphere, of this type, it is elongated along this axis. This is z axis and this is xy plane, xy plane. This is elongated at z axis. Then x square by b square plus y square by b square plus j square by a square equals to 1, and you may write this a square by b square plus j square by a square equals to 1, where a is equals to x square plus y square. Now you know the q0 equals to, expression for q0 was like this, integration over rho 3z square minus r square dv. This was the expression for quadruple moment. Now this expression comes out to be 1 by for nucleus, this rho 3z square minus r square. Now dv will be how much? Dv will be equal to s d phi dz d phi dot dz into ds. Now if you perform this integration, then this will come out to be 2z by 5 a square minus b square. Now writing the expression a square minus b square, I'm sorry, is not visible. Five a square minus b square. Now if you write the eccentricity epsilon to be a square minus b square by r square, the average of r square, then q0 comes out to be 2 by 5 z epsilon r square average. So q0 comes out to be this value, considering the deformation of the nucleus, that is Prolet spheroid. Now quantum mechanical calculation gives that value q equals to I into 2i minus 1 by I plus I1 into 2i plus 3 into q0. So the estimation of q and q0 theoretically can be understood. Now all these discussions till now is based on how quadruple moment of a nucleus can be changed if the nucleus is deformed from spherical shape. Now let us move to the more practical problem, that means vibrational and rotational motion. Now we are discussing first vibrational motion. If the nucleus is deformed from spherical shape and we are considering the deformation in any mode, not only quadruple but in any mode, then we can write the expression as we have written previously. So this r is equal to r function of theta and phi, r will be equals to r0 as previous 1 plus alpha nm y nm theta phi. Put this second bracket. We know this expression where this alpha nm is the deformation parameter and this is spherical harmonics. Then kinetic energy, then Hamiltonian H will be equals to T plus V. Hamiltonian H will be equals to T plus V. This T equals to kinetic energy. This is related to the half Bn, this alpha Nm dot square, alpha n dot square plus half Cn for nth mode. We are considering this will be alpha nm dot square C alpha nm square. Dot means derivative with respect to time. So this parameter Bn, this is called inertial parameter, means this is equivalent to mass. This is inertial parameter, and this is restoring, related to the restoring force. This is related to the coefficient of restoring force, K in case of simple harmonic motion, right? Then angular frequency for the nth mode omega n would be equals to how much? You all know, Cn by Bn, nth order. Now Up to this, we can say, but there is no such theory how we can calculate Cn and Bn. There is no way, because nucleus is a very small quantity. So how we can measure Cn and Bn? There is no such work. Only way is we have to guess their properties and fit with experimental values. That is the only way that we have. Fortunately, Lord Rayleigh has done some work for liquids, and in one of the nuclear models, Bohr has suggested the nucleus to be a liquid drop. In nuclear physics there is a liquid drop model. So the work of Lord Rayleigh was applied here, assuming nucleus to be a fluid, a liquid drop. From the work of Rayleigh, we can see that Bn was given this value. Bn was equals to rho r0 to the power 5 by n for nth mode. Rho is the density, r0 is the radius of the liquid drop, and n is the nth mode. And Cn was given this value 5r0 square n minus 1 n plus 2 minus 3 z square e square by 2 pi r0 n minus 1 by 2n plus 1. This was the value given by Lord Rayleigh's work, obtained by Lord Rayleigh's work. Now, from these expressions, two things are common. First thing that for n equals to 0, for n equals to 0, Bn tends to infinity. So omega n tends to 0, omega 0 tends to 0. So first state, excited state, is absent. Frequency is 0. For n equals to 1, from this expression you see that Cn equals to 0. So this implies omega 1 is also equals to 0. So the first two modes of vibrations, omega 0 and omega 1 are absent. So we are left with the next mode of vibration. This is monopole term, this is dipole term, and the next term would be quadrupole term. So first two modes of vibration are absent. We are left with the first important term is the quadrupole term. Now angular momentum, we are considering angular momentum quantum number of the nth phonon, that is, whose quantum number is n, and orbital quantum number is n, and azimuthal quantum number is, magnetic quantum number is m. So for nth phonon, for nth mode of vibration, there are 2n plus 1 number of m values. So this is a degenerate state. Right? And its parity would be defined by minus 1 to the power n. As momentum increases with the quantum number, as n increases, value of momentum is also increases. So the value of En, energy, En also increases very rapidly with the increase of quantum number. Now if we calculate the ratio of frequencies, say omega 3 by omega 2. Then the value obtained will be equals to root over omega 3 means, I'm sorry, first quadrant C3 C2 into, this will be in reverse direction, B2 by B3. Now, if we substitute these values, then this comes out to be what values? Root over, you will work it out on your own hand, approximately equals to 2. Means omega 3 equals to approximately equals to twice omega 2. And similarly, omega 4 approximately equals to 3 omega 2. Now, this is a straightforward relation that the frequency of the octuple phonon vibration is twice that the frequency of quadruple phonon vibration, and the frequency of 2 to the power 4 phonon vibration is thrice the frequency of quadruple phonon vibration. Now let us see what the experimental observation is presenting to us. For example, the collective vibration about the spherical state, the first excited state of quadruple phonon state, that is the quadruple phonon n equals to 2 state. Next excited state will be octuple phonon state, octuple vibration with angular frequency omega 2. So its energy will be twice the value of single quadruple phonon vibration. Now coupling two phonons of angular momentum 2 units, because n value is 2, gives rise to 3 states. 2 j values, say there are 2 j values, 2 are equal values, 2 units of j values. These 2 values can give rise to 3 values. If they are oppositely parallel, then this equals to j equals to 0. If they are parallel, then j equals to, this is called 2 plus 4 plus. And if they are aligned in form equilateral triangle, then 2, then this will give 2. So these are the allowed values if two phonon with frequency, angular momentum of 2 unit coupled together, these 4, 2, 0 plus, 2 plus and 4 plus will be obtained, and their energy difference will be very small. Now, for the nucleus of PD106, what we have found experimentally is this. Experimental value we have found is, this is 0 state, this is 2 plus state, and these 3 states, 0 plus, 2 plus, 4 plus, this is 0 state, this is energy 0, 0.512 MeV, this energy 1.123, like that, this is 1.229. Theoretically we can predict, we don't know the value of this, so this is 0. Obviously we take this thing to be h cut omega, of course, first h cut omega, then is this energy will be twice h cut omega. So if we take h cut omega to be 512, so twice h cut omega equal to how much? It will be 4 to 1.024. This will be the actual value of the twice h cut omega, which is somehow very close to these values. So from this we can say that our deduction or our understanding of the vibration of the nucleus matches with the experimental observation. The next classes we'll discuss about rotation of the nucleus and another important model which is called Nielsen unified model, which is quite complicated model, but I will try to present it in a very simple way. In the meantime, I will suggest the students to go through the book of S.N. Ghoshal. All the derivations that I am doing here are done there. You can go through it. What I have done here, just make it simple to understand. Thank you very much.